One other thing that you're going to need to be able to do for this kinetic unit is to be able to calculate rate. What rate is equal to is simply the change in concentration of either your reactants or your products, so products or reactants, and the brackets is shorthand for concentration, divided by the change in time. So let's look at an example problem for this. So let's say we have 100 grams of NaCl dissolves in 2 liters of solution in 30 seconds. So we know our change in concentration. We're going to actually use all 100 grams, or all 100 grams is going to dissolve in 30 seconds in 2 liters of solution. So that makes things a little bit trickier because our rate equals change in concentration of products or reactants over change in time. Doesn't say anything about the volume of the liquid in which it dissolves. But we can use a different way of measuring concentration to help figure this out. So the measurement for concentration that involves both amounts, takes amounts and volume of the solution into account is our molarity. And our molarity equals moles over liter, or liters, I'm sorry. So let's find the molarity, or the concentration of our 100 grams of NaCl in 2 liters. So first we've got to find our moles of NaCl. So we have our 100 grams of NaCl. We get our molar mass of NaCl, and our molar mass of NaCl is 23 plus 35.5, so 58.5 grams over 1 mole. So we get 1.7 moles of NaCl. And for our molarity, it's moles, 1.7 moles divided by liters, but we actually have 2 liters. So 1.7 divided by 2 equals 0.85 is our molarity. So now we have our concentration, and our time is over 30 seconds. So our rate is, so with our rate being change in concentration over change in time, our change in concentration is 0.85 molar is going to dissolve in 30 seconds. And our time is always going to be in seconds. So if you had 1 minute, you'd have to convert it to 60 seconds, 2 minutes, 120 seconds, and so on. So 0.85 divided by 30, and we get a rate of 0.03 molar per second. So that's how we can calculate rate given a mass, a volume of solution, and the time that it takes for that amount of solid in that volume of solution to dissolve. We just take it and we use our moles over liter to get our molarity, which is a measure of concentration, divided by time to get our rate of 0.03 molar per second.